What is up, guys? It's Mohannad and Najmus, and today we're going to be talking about forces. We're going to be talking about how they're measured, how they're all around us, how they're working all around us, and so on. We hope you're going to like this video. Let's go.
First up, let's define a force. A force is a push, pull, or twist factor. Forces are everywhere. They're happening all around you. Gravity was first discovered by Sir Isaac Newton when he saw an apple fall from a tree. This incident happened when he was thinking about forces while working in nature. Gravity is a type of force. An example of gravity. When I drop this apple, the gravity pulls it towards the earth.
An example of a push factor.
Push factor. An example of a pull factor.
An example of a twist factor is when you turn this doorknob to open the door. We all measure things. We measure our heights, we measure distances, we measure how heavy things are. Wait, did I just say we measure things? Yes, we do. When we are at the grocers, the shopkeepers measure how heavy our groceries are. For example, 4 apples equal to 500 grams. In order to find out the correct amount of money we have to pay for each of the items we bought, but the shopkeepers don't really find out how heavy our groceries are. They only weigh our groceries to find the total mass. The results come out as kilograms or grams or probably milligrams. On the other hand, we use meters or kilometers or centimeters to measure distances, people's heights, how long things are, etc. When we measure forces, we use a special kind of measurement unit called newtons, which is also named after Sir Isaac Newton.
Most people make this mistake. They don't understand the difference between mass and weight, but the difference is super simple. Mass is the amount of particles inside an object. On the other hand, weight is the gravitational force that attracts or pulls an object to the surface of the earth. The weight of an object depends on its mass and the planet. The more the mass an object has, the heavier it is. Easy peasy. There are actions in which you don't see any force working on, but there's definitely some force always present. Normal force is the support force exerted upon an object that is in contact with another static object.
Now I'm going to demonstrate an example of normal force. So as you can see, I'm sitting on this chair. Now you may be wondering what kind of forces are working on me. Well, there are 2 types of forces working on me. Number 1, as we all know, is gravity that's pulling me down to the earth. And there's another force that you may be wondering about, which is normal force. Without this force, this chair would sink into the ground with me on it. Friction is the force applied to the surface of an object when it moves against the surface of another object. For example, in this video, when I pushed the benches, I could not move it a certain distance right away. It took me a little time to move the bench because friction was working between the grass and the benches. As a result, there was force slowing down the benches, and therefore it took me a little bit of time to move the benches the certain distance.
Alright guys, so as you can see I have a rubber band and I'm going to show how elastic force works. When I stretch the rubber band, it expands, and when I release, it goes back into its original form.
Alright guys, enough facts and information, enough of the brain getting crammed, let's have some fun. So, I have 2 magnets in here, and 1 magnet. These are all the same type of magnets. And I also have a metallic safety pin, which I'm going to be using, and I'll get one end of this attracted to the bunch, and lift the other end up with this magnet. Let's see how it goes. Oops, sorry. So let's see how it goes. Really quick reaction, guys. Check that out. Oh, and don't forget this. Magnetism is a force of attraction or repulsion between magnets. However, magnets can only attract metals or alloys. Alloys are combinations of metals. For example, bronze. It is a combination of copper and tin.
But there is one more thing.
When 2 magnets have the same poles facing each other, they'll repel. But when one magnet has a north pole and the other magnet has a south pole facing each other, they'll attract each other. Alright guys, so as we all know, magnets with unlike poles will always attract each other, while magnets with like poles will always repel each other. So, as you can see, I have 2 magnets in here, and now I'm going to push that magnet with this one. Let's see how it goes. So as you can see, I can't get them to attract. They're pushing away each other. So now I'm going to attract that magnet with this one. Let's see how it goes. Upthrust force is the upwards force that goes against gravity and pushes an object upwards, especially in a fluid. A fluid can be air or liquid. There are 2 types of upthrust force. There's buoyancy, which is a force that pushes an object upwards when it's in a liquid, typically water. This helps the object float on the liquid. For example, if a person is floating in a swimming pool, there's buoyancy that's keeping him or her afloat. There's also air resistance, which is the force that slows down an object in midair if it's in motion. For example, when a skydiver jumps from a helicopter or aeroplane, he or she is slowed down when he or she opens up the parachute. Due to having a large surface area, the parachute has a lot of air resistance working on it. Therefore, it slows down the skydiver in mid-air. Without air resistance, the skydiver would fall at a much quicker speed downwards towards the ground, and boom! Alright guys, so as you can see, I have a small bowl, a small white bowl, and a huge bucket of water. Now what I'm going to do is, I'm going to make this bowl float on the water. So I'm guessing that this bowl will surely float on the water, and that's because of 3 reasons. The surface area of this bowl being spread out, the fight between gravity and upthrust, so upthrust and gravity cancelling out each other, and the density and volume of this bowl being less than the density and volume of the water. So let's see if my hypothesis is correct.
Forces are really important in our daily lives. Without forces, we wouldn't be standing on Earth right now. Without forces, everything would be out of control. We would be floating about everywhere, as if we were in space. It would be very awkward to live on Earth without forces. thanks for watching till the end of the video. We hope you enjoyed it.
Be sure to subscribe to Tech Lord, put a comment down below, and give this video a big thumbs up.
See ya.
Peace.